How are you, everybody who is watching this video? My name is Olenjolai from the beautiful, fantastic country called the United Republic of Tanzania. I'm very happy to welcome any of national and international undergraduate students who is pursuing scientific or engineering or scientific or engineering or social science courses in undergraduate level. I'm very happy to be with you. I would like to take this moment to welcome you into our online platforms that's called the Online Undergraduate Polytechnic Institute of Tanzania (Olenjolaim) simultaneously because we are solving mathematics. I would like to welcome you into one of our YouTube channels. We have 6 YouTube channels, and you will see the link below the descriptions of this video for the other official YouTube channel. And this our official channel is called the Online. So it's online. So possible that you don't see it. That's why I'm rewriting it properly. Online Undergraduate Polyinstitute of Tanzania (Olenjolaim). Undergraduate, this is the abbreviations of undergraduate. Polyinstitute, this is the combination abbreviations of the two words Polytechnic Institute of Tanzania (Olenjolaim). Well, I would like to remind you the visions we have in this online platform. First of all, we'll be having a focus of curriculums of United Republic of Tanzania. However, that scientific and engineering mathematics for undergraduates is universal, is common. So this content might be used in Europe. It might be used for the students who are in United States. It means North America, South America, Asia, African continents, including that North America, North of Africa, South Africa, Central Africa, Asia, Australia, including Israel, including China, and different places of the world. Students that might enjoy the beauty of engineering and scientific mathematics. So I would like to spend couples of the minutes to remind you about the vision that you have, because you have a visions in these platforms or in this online school. Okay, so what the visions in your mind? Well, God has revealed these kinds of the vision that I should be a part of teachers who would like to prepare a special group of students, engineering students who are expected to be engineers, who will be ready to take the classroom instructions in engineering courses or scientific courses and the mathematics to combine with the knowledge of the Word of God in order to solve real-life problems. It's possible to combine the physical knowledge and the wisdoms of the Word of God, or the knowledge of the Word of God, in order to solve real-life problems. So our main objective in this platform is to help our students to solve real-life problems. However, that we have some specific objectives, and one of the specific objectives is to help our students to pass the continuous assessment, such as testing assignments, and solve some of the tutorial questions. And not only that, we have a second specific objective, that to help our students also to understand and love the beauty of engineering and scientific mathematics. And our third specific objective is we want to see our students graduating with high performance in engineering and scientific mathematics. Well, we have some departments in these online schools. One of the departments is called the engineering. This is the abbreviations of engineering and scientific mathematics. And the models of the course that I'm teaching you today is called differential equations and complex variables. Possibly that in our country it's called the OIT. Maybe this course or module is called in another name. So don't worry about the name. The issue is focused on the contents. So in these departments of engineering and scientific mathematics, I will be teaching you 12 modules or 12 subjects. 4 modules will use the reference of the Dar es Salaam Institute of Technology in United Republic of Tanzania, and 4 modules will be used the reference of University of Dar es Salaam, and 4 courses also will use the reference of the curriculums of University of Dodoma, because in Tanzania we have TCU and the NACTE. So those are the 2 accredited. Again, before we begin the sessions, because we are in lecture 3, powerful, that's titled as powerful series method for online differential questions. Again, when I'll be either now or when I will continue with the sessions or after the session, you might feel from your heart that you want to offer our Father who is in heaven or our God the free willing offering in order for you to participate and support the running cost for this program, so that the hundreds of the lectures or videos will be in air and can be accessed at any time and anywhere worldwide through our YouTube channels and other platforms that will be posting our videos and training students worldwide at any time. And also, at any time, we'll be training our students at any time and also anywhere, and or with a free cost too. Don't charge any cost to you. So then this is the module or subjects of the second year. And actually, that as we say that we are in session 3. And before we begin the session 3, I would like to ask you if you have done the homework I left you. This is quick review of lecture 2. So I left the homework there when I have been teaching about indexing and shifting of the indexing. So I left the homework. Did you do it? So if you have done it, submit in the comment sections so I can review your homework, and even some other students worldwide, they can see your homework. So remember that until now in this module or course, we have covered the lecture 00, the general introductions of 40 of engineering and scientific, undergraduate engineering and scientific mathematics. And also we had the general introductions of differential, which is lecture 01 or lecture 1, the general introductions of differential, which actually focused about series, finite and infinite series. And also we had covered the lecture 2, which now I want to do the quick review. So in lecture 2, basically, I taught you about the meaning of index, what the meanings of the index, and then I taught you that in mathematics, you have 2 types of index, mainly, and then she said that we have counting index, and also we have summation index. So in the counting of index, we have 2 types of counting index. We have first counting index, and we have last counting index. Also, in the in this part, we say that in the second part or second type summation index, we have 3 types. So we have coefficient summation index, we have subscript summation index, and we have superscript summation index. So again, I taught you the concepts of shifting. I told you that this is very important. We're going to use it in the power series method, shifting of 40 of index. So we say that you can shift it. So remember the principle. We say that the principle is this one. If you raise the summation index, okay, summation index, possibly by a certain factor, maybe by 1, then you have to lower the counting index. You have to lower the counting index by the same factor. For this case, is by 1, and vice versa. Okay, so vice versa. So go through lecture 2 before you continue with lecture 3. So let us go to the business. So in this lecture 3, before I take you to the powerful series method, I would like to do corrections of one of the questions that I left it in lecture 2, so that to encourage you, possibly that you have got stuck. The one questions which was example 7. So example 7. So example 7, it has been written as write a given generic term. Write a given generic term. Okay, in generic term with x power n. It's x power n. And the given summation or series is x power 4. Okay, this is n is equal to 2 to infinity. This is n minus 1, then you have a subscript of n, then x, n minus 2, plus x squared, x squared, n is equal to 0 to infinity, and then here we have a subscript of n, x power n. So that was the question. So to solve this question quickly, this is the simple question for my students because I've already taught you. The first step that we have to, so the given series, there's a given sigma notation as two part, first part, second part. So the first step, because we'll be solving this question by following steps, we say that consider the first part of the series. The first part of the series. So to consider the first part of the series, here we have x power 4, and then we have sigma notation from n is equal to 2 to infinity. Okay, and then we have n minus 1, and then we have a subscript of n, then you have x, n minus 2, right? So to do this, first of all, we say that we have to take x power 4 and multiply with x power n minus 2 because we have the same base but different exponents, so we have to add the exponent. Before we raise and lower, we have to simplify. So this one from n is equal to 2 to infinity. So we have n minus 1 as coefficient. This we call this coefficient summation index, and a subscript of n, this is subscript summation index, and here we have x power n minus 2, then we multiply with x power 4, same base, add the exponent. So this one will make summation n is equal to 2 to infinite, then you have n minus 1, a subscript of n, then you have x power n minus 2 plus 4. Okay, so then this will make what? So this will make summation n is equal to 2 to infinite. So you have n minus 1, a subscript of n, x power n plus 2. Right? So that's the first part. So we have write that series in terms of x power n. So it means that our superscript is n plus 2. So in order to have x power n, we have to lower the summation index by 2 and we raise the counting index by 2. That will be the second step. So the second step, we say that we have to lower the summation index. Say summation index. We have to lower the summation index by 2 and the raise counting index by 2. So we are still doing the first part. Do you enjoy the beauty of engineering and scientific mathematics? Please tell me in the comment section. Okay? So then we say that for that case, we have the sigma notation from n is equal to 2. We say we have to raise this by 2, okay, to infinity. But even infinity can raise by 2, but the answer will be infinity. And then the summation index will be n. So we have to lower it by 2, as we said. Each summation index, you have to lower it by 2. So here we have n minus 1 minus 2. And then you have a subscript of n minus 2. Then here we have x power n plus 2 minus 2. Right? So good. So then we say that this is equal to what? This is equal to the summation. 2 plus 2 is equal to 4. Okay, the last counting index will be infinite. And then this will be n minus 2. Then n minus 1 minus 2, this is equal to n minus 3. Then you have a, n minus 2. Okay? And then you have x. Then 2 minus 2, it is 0. So it means it's n. So the first part, we have already expressed it in generic terms of x power n. Remember that this is the fundamental of power series solutions that we'll be solving near to the ordinary point and near the singular point. We'll be using the existence theorem and we'll be using Frobenius theorem. So I'm preparing you for what we'll be doing in the long series, because we are going to use series. And this power series means that we'll be solving ordinary differential equation, right? And then in this session or in this lecture, I'll be link what you know about how you can solve the differential equation, and then what you have to know about this new technique. So the first is the steady state. Steady state, now we say that we have to consider second part of the series. So the second part of series, you say that we have x squared, then you have summation. So summation of what? N is equal to 0 to infinite, and then you have a subscript of n, x power n. So for this one, actually, without this x power 2, then the terms is already in the generic term. But because of this one, we can say that it's in the generic term. So we say that let us simplify. So how do you simplify? We have to multiply the exponents, okay? And then because they have the same base, so we have to add the exponent. Okay? So you have a subscript of n, and then you have x power n, and then we have to multiply with x squared, right? Great. So I'm solving example 7. If you did it, you have to check whether you are right or you're not right, so that you enjoy the beauty of engineering mathematics, especially differential questions and complexity variable. And this is the first part, which is called the differential equation. So we are solving differential equations, but we're using a different technique because these are differential equations. We formulate them from real life problems. So this is m is equal to 0, infinite. Then we say that this is a subscript of n, x power n plus 2, right? So then, according to the questions, you have to express these numeric terms in terms of 40, in terms of n, in terms of x power n. So we go for the first state. So the first state, we say that to express these numeric terms as x power n, we have to lower the summation index by 2 and raise the counting index by 2. So we say that we have to lower summation index. How many summation index you have here? We have only 2. Subscript summation index and superscript summation index. In this part, we don't have coefficient summation index. So lower the summation, lower summation index, okay? And let us raise the counting index. So let us raise the counting index. Okay, let us raise the counting index. So if that's the case, you say that this is our sigma notation, and this is n is equal to 2, infinite. So as we say that you have to raise the counting index by 2, and this one we have to lower it by 2 and raise by 2. So then we have subscript n plus 2, and here we have for the summation index we have to lower by 2. So it will be a n minus 2, and here it is n plus 2 minus 2. So simply this part will be summation from n is equal to 2 to infinite, and hence a n minus 2 x power n. So then now we say that we go for the 50th state. So 50th state, we say that let us write overall series. So the overall series for this case will be that the first part of the series plus the second part of the series. So we have to do so many practice on lowering and raising summation and the counting index, or lowering and raising the counting index, because we're gonna use this technique to solve so many ordinary differential equations which contain we call it ordinary or polynomial functions as linear coefficient. So now we say that these defined expressions, we had defined expressions, we had this defined expression. So therefore now the generic term, is what? Is that one. So we say that is in fact, so it is sigma notation. N is equal to 4. to infinite. Then this is n minus 2. And this is n minus 3. We have a subscript of n minus 2 x power n. Hence, we have to plus this what? This sigma notation. And this is n is equal to 2 to infinite a subscript of n minus 2 x power n. So this is the final response. Okay, so keep on enjoying the beauty of engineering mathematics. And now let me take you under the powerful series method for ordinary differential equation. So let me take you into the powerful series, the general introduction. General introduction of power series method. Power series method for ordinary differential equation. ODE means for ordinary differential equation. So before we take you into the power series method, we have to remind you what we taught you previously. Okay? So what we taught you previously in solving differential equation. Then afterward, we add these new informations of power series method. Okay? So in previous modules, so you say that in previous modules, when you say in previous modules, that we covered during advanced education or during the ordinary diploma education. Okay? Modules or courses, because in some of the institutions we call them courses, we learned several standard techniques. Okay, to solve the ordinary differential equation. Ordinary differential equations. Okay, ordinary differential equations. So we say that these ordinary differential equations contain the constant coefficient. Contained constant coefficients. Constant coefficients. Okay? Constant coefficient of their derivatives. What does it mean? We say that generally, the general form, the second order ordinary differential equation. We have zero order ordinary differential equations. We have first order ordinary differential equation. We have second order ordinary differential equation. We have third order ordinary differential equations. We have higher order ordinary differential equation. So for instance, for the second order, which we solved in most cases, we used to solve as A, second derivatives of y with respect to x plus b, first derivative of y with respect to x plus c, y is equal to 0 possible. Right? So we say that where, first of all, the condition that means that in order for this equation to be second order, a should not be equal to 0. So we say that, but we used to solve this one whereby this A, B, and C are coefficients, are constant numbers. So these are what are constants. So what it means of constant, they are numbers, they are not variables, they are not functions, they are constants. So we had first order differential equation, we had second order differential equation, we had zero order differential equation. However, we didn't deal with it in mathematics, but we dealt with it in chemistry. Then we had third order, fourth order differential equations, higher order differential equation. So we say that we used to solve these problems by using different methods. So we solved it, for instance, that if you say that this is question 1, so you say that we solve the equation 1, okay, by using different techniques. Okay, different techniques depending on the format. So different techniques. So for instance, we can solve it maybe by using integrating factor, if you remember. Integrating factor. You can solve it also by using Bernoulli's principle or Bernoulli's method. You can solve this differential equation of second order by using exact method. I'm not sure if we can. Yes, even we can solve also by using directive integration. You can also solve it by using Laplace transform. We used to solve it by using Laplace transform, especially in calculus. We can also solve differential equation by using separating method. So when you say about these terms of the differential equation, example of this differential equation that we use to solve by using this technique is, for instance, you have 6 second derivative dy dx squared plus 4 dy dx minus 2 is equal minus 2y is equal to 0. So this is the one of example. But also you can solve, for instance, that we have, let's say, dy x squared plus y is equal to 0. So these are the examples of differential equations. We use so many techniques to solve them. Now the point you have to remember, these ordinary differential equations had constant coefficients. Constant coefficient, for instance, here the coefficient is 6, is a constant number. The coefficient here is 4, is a constant number. The coefficient here is 2, is a constant number. Coefficient here is 1, it's constant number. Coefficient here is 1, it's constant number. Right? So use those different techniques on solving this differential equation. So for instance, before even we take you into this power series method, we say that we used to call this, there's a concept we used to call it auxiliary equation. So for instance, that maybe solving auxiliary ordinary differential equation. Solving auxiliary. So we want you to understand what are we doing, why do we need this power series method. Auxiliary. So auxiliary. So you have to understand auxiliary ordinary differential equation. Solving auxiliary ordinary differential equation. So as I say that the general form, generally, we say that we have A, y double dash plus B, y single dash plus C, y is equal to 0. So this one, if we formulate, can have m squared, can have auxiliary equations, which is m squared. Now A m squared plus bm plus c is equal to 0. So we have, in order to solve these differential questions, we say that first of all, we have to recall, if you do remember, you have to recall what the general formula. We taught ordinary diploma students in third year the model called the conics and differential questions. We call the general formula. General formula of solving quadratic equation. Why do you have to recall? Because this is the quadratic equation now. Okay? So the general formula for this case, we say that m is equal to negative b plus or minus square root of b squared minus 4ac over twice a. So remember also in calculus, I taught you about elliptic partial differential equations, parabolic partial differential equations, and I taught you about parabolic partial differential equations. So use the concepts of discriminant to classify them, right? So similarly here, by using this concept of discriminants, you can classify the solutions. The solutions due to the nature of the roots. So remember that this is square root of b squared minus 4ac. In mathematics, we call it that this is what? Discriminant. So discriminant of the quadratic equation. Discriminant. Okay, so we call it discriminant. So we have three cases for this case. So if you solve, we have case 1. We say that if this discriminant, which is square root of b squared minus 4ac, this one is greater than 0. So if it's greater than 0, then we say that the roots of the quadratic equation are real roots. So these are real roots. So if this is the conditions, we say that the roots of quadratic equation are real distinctive roots. We are just reminding you, so you have to understand where we from in mathematics, because mathematics, you have to link the concepts in order to understand. Okay, I know that you are really waiting about power series method because you've been confused by your teacher in the class. Don't worry that we're gonna do, or I'm gonna teach you, and you'll like it for the rest of your life. So we say that if that's the case, so we say that the complementary solution, because we have particular solution, complementary general solution. Okay, general solution of what? Of your quadratic equations, which is y double dash plus b, y single dash plus c, y is equal to 0. This one will be y is equal to arbitrary constant e, then power e, then here possible that you have alpha x plus what? Arbitrary constant b, e power beta x. So what is alpha? So we say that we have here we get alpha and beta are two distinct roots. Two distinct roots, means two different roots. So this will be the general solution for the problems or for the ordinary differential question, which containing constant coefficient. Okay? In case you have any questions, don't hesitate to ask in the comment section. That is case 1, right? Case 2, this is case 1. Case 2, we say that if this discriminant, which is b squared minus 4ac, is equal to 0, then we say that the quadratic equation QE, the quadratic equations, has two equal roots. So the general complementary solution y is equal to e power alpha x, then you have a x plus a little constant b. This isn't? Let me check. Yes. So we said that whereby alpha is the root. Okay? So this is the general solution. But if you are avoiding constant coefficient, if you have polynomial coefficient, it becomes cumbersome, it becomes a challenge to solve by using this technique. So I'm just quickly reviewing them in order to show you the limitations. This can only solve second order differential questions of ordinary differential questions, which contains the constant numbers and their coefficient. And so case 3, we say that if now the discriminant, which is b squared minus 4ac, is less than 0. So then, for this case, then our quadratic equation has a complex root. So for this case, there's complex roots. So if we complex root, for instance, that you are solving for y, so it will be alpha plus or minus beta. So beta is imaginary part, alpha is the real part. So the general complementary solution for this case, we say that it is a power is e power alpha, which is the real part, alpha x. Then we say that this is a cosine of beta, which is imaginary part, plus I sine of IB. Plus IB, imaginary part, B sine of beta. Okay? Sine of beta. So this is the general solution for that case. But again, you have case 4, which I know that most students they didn't enjoy it. And in case 4, we say that if now the differential question is given as this one, y double dash plus or minus n y is equal to 0. So second derivative plus or minus n square y. So the goodness of this equation is relating the equations of simple harmonic motion. So this is the module for the second year at the Recent Institute of Technology in many institutions and colleges and university also. It's a second year module, whether first semester or second semester. So y double dash n square y is equal to 0. So let us begin. This is y double dash plus n square y is equal to 0. Right? So if we express now, this becomes a m square plus n square is equal to 0. So it means that if you express it, m square, there's no n, because coefficient is 1. M square is equal to plus n square is equal to 0. So to get n, this is equal to negative n square. So to find the square root, find the roots of m is equal to plus or minus n. And then we have our imaginary part out. So then we have to come back. So that's our solution. So you have to come back onto this. So in this case, we say that the root of this differential question is equal to what? Is equal to 0 plus or minus NR. So for that case, if you recall the general complementary solution here, so y is equal to E, alpha it is 0, and then times A cosine of beta. Beta here it is M. Okay, so mx, because this is x, we have x here, and also we have x there. Okay, I just forgot. So then plus what? Plus a beta constant b, then you have sine of nx. So e power there is 1, so y is equal to what? Is equal to a cosine of nx plus, here we have also imaginary part r. So I beta, then we say that sine of nx like this. So this is the general solution for that case. Right? So homework now for you as a good student. This is homework 3. So homework 3, now write the solution for this y double dash minus n square y is equal to 0. Very simple solution. And that's not the homework, the quiz. Pause the video and then try to write the solution for this. So this is quiz. Pause the video because you've been following me, and then write the solution for that problem. Okay, try it yourself. Don't worry, you can write the general solutions for that ordinary differential question. So now, solution of the quiz, I believe that you are done. So we have y double dash minus n square y is equal to 0. This simply saying it's equal to m square minus n square is equal to 0. So m is equal to plus or minus m. So to have the general complementary solution. Now complementary solution, we say that this is y is equal to, we say that the arbitrary constant a, then you have conj of x plus arbitrary constant b, then you have sinh of x. Sinh of x. So this is the general solution. Very important solution. Okay. I quickly reminded you also when we've been learning about the partial differential equation. So that is all about solving ordinary differential equation which contain constant coefficient. What if now the coefficient does not contain a constant number? That's the challenge now. It's containing the constant function. So now this is the challenge. The real world problems in engineering. Can be described, describe this problem mathematically, can be described in form of ordinary differential equation with variable coefficient. variable coefficient, not constant coefficient, right? So in this case, we can't use all of those, possibly 4 or more than 4 previous methods to solve them. Why? Because this method they do fail. They only hold it if the coefficients are constant numbers. So you say that in this case of solving these real life problems, in this case, all previous methods that we have taught you, all previous methods of solving ordinary differential equation will fail. So you say that if that's a problem now, so this is the problem. Okay, so you say that in order to solve this ordinary differential equation with variable coefficients, variable coefficient. Variable coefficients. Okay, we need a powerful series method. Powerful method. And this powerful method is the one that we call powerful series method. So now to solve so we say that coefficient of ordinary, so we say that coefficient of this ordinary differential equation are function of the independent variable. Function of the independent variables. Dependent variables. Okay. So you see that the power series method power series method can solve this differential equation. The power series methods more than one can solve these problems or the ordinary differential equation with variable coefficient. With variable coefficients. Variable coefficients, right? What does it mean? So it's a general form of so let me general form of this ordinary differential equation. Of this ordinary differential equation. Okay? So what I would like to say, we say that from the previous general form, which is A, y double dash plus B, y single dash plus C, y possibly is equal to 0. That's one format of writing. Or A, second derivative, dy dx squared plus B, dy dx plus C, y is equal to 0. So that was the previous format. So we say that the ordinary differential equation with variable coefficient, the general form of ordinary differential equation, right? Or second order ordinary differential equation. Second order ordinary differential equation with variable constants, with variable coefficients. With variable coefficients, right? Is given as, so this is given as P of x y double dash plus Q of x, very important format, y single dash plus R of x y is equal to 0. So this is the first general formula of these ordinary differential equations. Again, we say that if that the case, we can also rewrite this formula in this form. P of x b dx squared plus Q of x dy dx plus R of x y is equal to 0. Okay. So this is a general form. So you say that where P of x are the function of x, where P of x, Q of x, all of these are capital letters. So even this P is a capital letter. And this notation is used well. R of x are function. So these are functions of x. Function depending on what? On x. Okay? And under this condition, I say that P of x should never equal to 0. And here P of x should never equal to 0. Beautiful? If you enjoy the beautiful of engineering and beautiful mathematics, tell me in the comment section there so that we will celebrate together. So you see now the form of the general questions that we are going to do is this coefficient of differential derivative, second derivative, first derivative, and function. We made the functions, not the constant number like 2 or 0.2 or 7 or 8 or 10. Because the real life problems in engineering give us or present or model some physical phenomena by the aid of this form. Interesting? Okay. Again, we said that from these general questions, we said that we need also to know some piece of information. We said that the condition of the solution of the power series solution, series method to be employed is P of x, Q of x, these two functions, and the R of x should be, R of x should be polynomial function, should be 1. This should be polynomial function. We can do this trigonometrical function, polynomial function, and then and also the function should be analytic. When we are learning about the analytic function. When I'll be teaching you about complex variables, I'll teach you, and especially that the part of differentiation, this limited differentiation continuity, and I'll teach you about the analytic functions and non-analytic functions. So these are the conditions for solving ordinary differential question with coefficients of 40 of constant of variable coefficients. Right? So that is the general formula, as I said. I'll give you some examples. This is P of x, y double dash, plus Q of x, y single dash, plus R of x, y is equal to 0. Okay? So example. Y double dash minus 4 y single dash. For instance, this I'm just going to run random. Okay? So x squared minus 4y squared, x minus 1, y is equal to 0. So you see, coefficient is a function, coefficient is a function. So I say that this is plus what? So this we say that possibly plus x cubic y is equal to 0. So then we say that this is x squared plus 1 y double dash plus 3x possibly y single dash minus y is equal to 0. Right? Okay, so these are some of the examples of ordinary differential equation with variable coefficients as functions of x, and these are the functions of polynomial function. However, that when we'll be dealing about the ordinary point and singular point, we might find the coefficient of the functions is not a polynomial function. Okay, it's not a polynomial function. So these are the sample questions that we are going to deal with them, and you see that the situations it is a little bit challenging. Okay, so that's all about these examples. So now you can see that the directions of where are we going to. Okay, so after covering this concept now, again in my heart, I would like to mention just applications of what? Applications of ordinary of power series solutions. So these applications of this form. So let me pose a simple question here. What are the applications? What are the applications of ordinary differential equation? Ordinary differential equations of this form. That's the question. So basically we have 4 types of differential equations which employ these concepts. The first one is the Bessel. So the Bessel equation. Bessel equation. So this is x squared z plus x dx plus x squared minus this is equal to 0. That is the Bessel equation. We are going to discuss it later. The second equation is called the Legendre equation. Very interesting equation in applications of differential equation. So the Legendre equation. And also solve these Legendre equations, we are going to generate general polynomials. So the general equation is 1 minus x squared. Then you have second derivative divide x squared minus twice x twice xy dy dx one minus x squared, second derivative minus twice xy dy dx plus alpha. alpha times alpha plus 1 y is equal to 0. That is the Legendre equation. Okay? Then you have the Iris equation. So this is still introductions of power series solution. So the Iris equation of ordinary differential equations with constant, it's a variable coefficient. So this one is the simple equation minus xy is equal to 0. Iris equation. Okay, so you have the first equation. The first equation is the first, the Euler equation. The Euler equation. The Euler equation. The other equation, which is this x squared, we cover it in the master studies. X squared, second derivative of y respect to x, plus alpha x, dy dx, plus beta y equal to 0, where alpha and beta are constant. So these are constants. So alpha and mu and beta are constants. These are constants. So that's Euler's equation. So ordinary differential equations, you see that here. So I'm going to explain. These we call them, they are falling under this subject because, first of all, you see the coefficient of second derivative coefficient of first derivative coefficient of the function. So this is the function, polynomial function, polynomial function, right? Enjoy it. Then in these equations also you see the environment that which has been built. So we find that in this case, have a sequence, everything is clear. So that is the general equation. So you see that this is the function, here equation is a function, that's the kind of the constant number, etc. Then we have the Iris equation, which is second derivative of y respect to x minus xy is equal to 0. Right? So you see that actually that here it's a little difficult to see the equation. Okay, so it means that you see that what will happen. But again, you said you have the Euler equations, which is differential equation. So that in this one, this is the function, this is the function, and this is the function, right? So then that's what you have to enjoy for the rest of your life about this, at least this 4 questions. So then this is the end of this lecture 3 of a powerful series method for ordinary differential equation. Thank God who have been with me in the preparation. So thank God who give me energy to teach this session for His glory. Okay. So I would like to ask you, make sure that you sign in with your emails, and then in case that you don't have, you should have one, and then you have to join onto this platform. So I'm really praying for everyone. I would like to invite you in lecture 3, lecture 4, when I'll be teaching about ordinary point. How we find the ordinary point? What does it mean? So that the next session or lecture, it should be lecture 4. So may God bless you abundantly. Remember that in case you want to offer your free will in Thanksgiving, you may use this telephone number 0759745331, and the registered name is Olenjolai. So you can send you a seed Thanksgiving offering, and then that will give you the feedback. So give you the feedback concerning about whether we have received your transactions or not, of any amount, because it's very expensive to run these programs in person, but God is faithful. So this is the end. I invite you to make the next session. That will be session 11 or lecture 11. May really God bless you abundantly until we meet. See you.